Section 3, simulate. This is the bracket demonstration. This is the type of demonstration you would give to a new customer just to show them how Creo Simulate works. So let's go to simulate. The materials have already been defined. For our displacement or constraint for this test, we're just going to say that these two edges are held fixed. For our force, let's turn our points on, and we're going to load this at these two surfaces, and also load this thing at a point out here in space, and say negative 20 pounds. Okay, so that's our setup. Again, Creo Simulate has a battle card. You can talk about all the great things and benefits about Simulate and its accuracy and its ROI, but we're just going to go ahead and just do a simple little test here. We'll call it a static 1. We're going to do a multi-pass adaptive convergence. Type convergence is 6. Hit OK and run. It will mesh and solve for us. Here's the status. That's complete. And let's go to our results. Let's do it from a template, static 1 and front. The two graphs show us the convergence, so those are good. I want to always review those. Right side is displacement. Displacement is very small, so we're going to delete that one. Here is stress. Stress is very high and concentrated in that fillet area. So let's go ahead and close out of here. Notice the legend 19 KSI is about where our number is. We want to run a sensitivity study. Pick on that analysis, and let's change that radius from 0.1 to 0.5. Let's do 5 steps. You can animate this if you wish to. There's 0.1, 0.2, 0.3, 0.4, and 0.5. So now we'll just run that simulation, basically 5 times, each time increasing the size of the round. So it'll build all 5 of those for us. Each time it will analyze it, and then we can graph the results and see how sensitive our design is to that change. So there's 1, 2, 3, 4, and 5 complete. Let's just graph one of the predefined measures. Let's just say von Mises stress, and there's our graph. Notice if we put that round at 0.1, our stress goes very high. Around 0.2, we get around 19 KSI, which is where we started, and then at 0.4, it'll be about 11 KSI. So that's great. So we could just make it at 0.4 and be done, but if we want to shave some weight out of this thing, we can use the optimization study here. So we'll say minimize the mass, leave that. Let's say that the stress von Mises should be less than 11 KSI. Displacement less than 0.0015, and then we pick our variables to change. Just go around the model, selecting each of these. And then for the radiuses, can go between 0.1 and 0.5. Initial 45 to 90. The mid curve can go between 1.85 and 2.1215. Tab width is 1 to 2. The tab bottom each time they also pop up for us. That one can change quite a bit, 1.05 to 2.5. And that one right there can go 2.125 to 2.5. Okay. And then we go ahead and run it. It takes about 2 minutes, so let's go ahead and just look at the results instead. We want to compare this to the original we ran. You can go ahead and run the optimization live. 2 minutes is not very long to wait. Here's the two compared. Make sure you check out the time, the legend to each other, and then you see that you have a common legend over here on the new model, which is about half the size as the original. There's really no stress at all on the model. Last step is to exit results and click on the optimization study, which is not here. Well, if you had the optimization study here, you would see opt 1, and then you can go info and optimize history, and then you would be able to step through the model and watch it as it changed.